All right, this is my third time making this video, so it should be outstanding. Let's get started on the properties of limits, our next topic. Before we do this, I do want to review something important, and that is if a function is continuous, you can just plug in the value to find the limit. And I'm going to add something even more specific to this so that we can do this more often. If the function is continuous at the value x is approaching, then you can just plug in the value to find the limit. So what do I mean by that? I mean, if I have something like the limit as x approaches 4 of 2x plus 5, we know this function is continuous. There are no holes, there are no issues with the domain. So all we have to do is take 4 and plug it in for x. In this case, we get 2 times 4 plus 5, which is going to be 8 plus 5, which is 13. Let's try another one. What about the limit as x approaches 3 of x squared minus 1? Well, again, that's continuous, so we can go ahead and plug in 3 into x, and we get 3 squared minus 1, which is 9 minus 1, which is 8. What about the limit as x approaches 5 of 2 over x plus 1? Well, you might say, Ms. Sorensen, this function is not continuous, right? It's not continuous at -1. If we would plug that in, we'd have a 0 in the denominator. That would be a problem. However, by adding what I added here, at the particular value x is approaching, we can do this problem by plugging in. So if I take 5 and I plug it into x, you can see there's no issue. It will be continuous at 5, so let's just plug it in. That works fine in this particular problem. So we'll have 2 over 5 plus 1, which is going to be equal to 2 over 6, which does reduce to 1/3 if we divide both the numerator and the denominator by 2. Okay. Just rearranging my computer real quick. Sorry about that. All right, let's go to the next slide. These are called properties of limits, and it might be worthwhile to kind of pause these videos and get these notes down. So go ahead and do that now. All right, so you're back. Essentially what's going on here is it's saying if you need to add 2 limits, just add their answers. If you need to subtract 2 limits, just subtract their answers. So an example of that would be, let's say the limit as x approaches 5 of f of x is equal to 6. Maybe that function of f of x is x plus 1. Who knows? And let's say the limit as x approaches 5 of g of x is equal to -2. I want you to take note of the fact that these are both approaching the same exact x value. So if they don't match, you cannot do these properties. As you can see, the c values have to match. They have to be the same value. So the example that would be the sum rule, which is this first rule right here, says that if I'm asking you the following question, what's the limit as x approaches 5 of f of x plus g of x, you might see it like that. You might see it with another set of parentheses. Well, that's just saying all you have to do is take the answers, L and M, and just add them. In this case, our L would be 6 and our M would be -2. So we're just going to do 6 plus -2, and that is 4. All right, now the next rule is the difference rule. And the difference rule essentially states that you just need to subtract these values if you're going to subtract f of x and g of x. So let's say we have this written a little bit differently, and it can be written differently, just as you can see in the examples. Maybe it says something like, find the limit as x approaches 5 of f minus g of x. That's the same exact thing as writing out this. It's the same exact thing as writing out the limit as x approaches 5 of f of x minus g of x. Okay, so don't get too confused by the notation. It's basically saying, hey, subtract those two limits. And that's what we do, right? We're going to do 6 minus, and then our g of x limit would be -2. And of course, 6 minus -2 is going to be equal to 8. All right, let's do the next problem here. So here we've got the product rule, which is basically saying if you have two limits, you're just going to multiply them if you're multiplying the two limits together. So for example, let's go the limit as x approaches 0 of f of x equals 2, and the limit as x approaches 0 of g of x equals 3. In this particular problem, if I ask you for the limit as x approaches 0, right, it has to match these two, of say f of x times g of x, or maybe perhaps it looks different. Maybe I ask you for f times g of x. These are all saying the same thing. Or maybe I ask you for the limit of f of x times the limit of g of x. Okay, and it doesn't, I could put parentheses around here or brackets, whatever you want. I'm basically saying multiply the two limits, and in this case, 2 times 3 is 6. All right, the next one is called the constant multiple rule. So in this case, I might ask you for something like this. I might say, what is 5 times the limit as x approaches 0 of g of x? And in this case, you would just do 5 times our limit, which we know is 3, and that's 15. All right, next up we have the quotient rule, quotient meaning divide. And so if I ask you to do something like divide the two limits, so I might ask you for the limit as x approaches 0 of f of x divided by the limit as x approaches 0 of g of x, that would be equal to 2 divided by 3. And of course, this problem might look a little bit different notation-wise. It might say something like the limit as x approaches 0 of f divided by g of x. It might say something like the limit as x approaches 0 of f of x over g of x, and you really technically should have parentheses. So just know that that means, hey, take my answers to my other limits and divide them. The last property of a limit is the power rule. And the power rule basically states if you know that the limit as x approaches, let's say 7 of f of x equals 3, and I ask you to do the limit as x approaches 7 of f of x squared, then what you're going to do is just do 3 squared, which is 9. Now, I'm not going to be too particular about the parentheses at this point. All I want you to do is identify that it's asking you to square that limit and then just evaluate it. All right, we're going to try another one, and we're going to combine all those rules. Let's say the limit as x approaches 11 of f of x equals 3, and let's say the limit as x approaches 6 of g of x equals, we'll go -2. If I ask you for the limit as x approaches 11 of 2 times f of x plus 4, and then maybe divided by g of x, you should immediately say either A, Ms. Sorensen, you made a mistake, or B, trick question. And the reason why is because these two don't match, so we can't do this process. So I'm just going to go ahead and change it so we can, but just know that if it is this actual problem on an exam, you would say not possible. I won't trick you like that, but I do want you to be alert of the fact that the numbers do have to match. So let's just go ahead and change this to 11, and now we know the numbers match. So what we have here is a simple plug-in problem. So we're going to have 2 times, instead of f of x here, we'll put the limit there is 3, then plus 4, all over my g of x, which is negative 2. So this is going to be 2 times 7 over negative 2. That's going to be equal to 14 over negative 2, which is equal to negative 7. You're basically just following the order of operations. All right, I hope that helps. Have you a wonderful day, and I'm going to go and have lunch. Okay, bye.